Then little bit more about the variation. What is the variation? Right? Assignable variation and the chance variation. Then more discussed about the assumptions of ANOVA, which was quite important. And then we have seen for Cochrane theorem, which is we are going to use it for ANOVA, and then we have stopped. That was the basic concepts. So this note is now available in your GC, so you can download it. Okay. This is something like t-test, which we have used it for ANOVA, like t-test and z-test. So you may use z and t here based on the like whether sigma will be known and unknown, okay, based on that. So if the sigma will be known, so z-test can be is going to be it's going to be x1 bar minus x2 bar minus mu1 minus mu2 whole thing upon sigma 1 square upon n1 plus sigma square upon n in bracket. So this formula one can use when sigma 1 sigma 2 unknown, one can use pooled variance. Okay, one can use pooled variance, which is s square. This is also known as the pooled variance. What is called pooled variance. This is you can use in paper 2. The criteria remains same when you reject h naught if and only if the mod of t value will be greater than t alpha by 2, comma degree of freedom will be, since we have two observations like two groups. Okay, so let's say n1 group and n2 group. So degree of freedom will be n1 minus 1, here n2 minus 1. So if I club it together, it's going to be n1 plus n2 minus 2. So this may will be the degree of freedom. But suppose instead of two population, we have a k population, k independent populations. Okay. Now we have a two populations, correct? Like mu1, mu2, and you are interested to check like mu1 is equal to mu2 and versus mu1 is not equal to mu2. Then you can apply t-test and you can that criteria is already you're knowing. So I'm just keeping that. Think of if we have a like k independent sample, right? And having the common variance is sigma square. This is the assumptions. Okay, make sure that we are just assuming that the k independent normal populations, like we are taking these observations from the normal population and having the common variances. Okay, that is our assumptions. So we are like the assumptions which I want to show, that is already proved, means they have just assumed that they have a common variance. What is my task? My task is to be check whether this all means are equal or not, versus now this can be written in different way also, that is there is insignificant insignificant difference between, or difference is insignificant difference between, because we have a more than one, so among all the population, I can write like this also. There is insignificant or not significant, I can say not significant. Insignificant you say, or you can say not significant. So there is an insignificant difference among all the population. Okay, that means insignificant means not equal. It means I will be saying not significant. Okay, versus all population means are not equal. Okay, that means there is significant. There is a significant difference among all the population. Okay. So my task is that to be check whether the all population mean of a group which we have, whether there is a significant difference or whether there is a no significant. Okay. So make sure that you always consider under null hypothesis there is a no difference. We assume there is a no difference. Can anyone tell me why we are considering this under H0, not under H1? Can anyone tell me why we are considering under H0 all population means are equal? Why not under H1? Anyone who can tell, who can explain? Maybe some part of that, no problem. At least you can try out. So that is all basics of your hypothesis. This is the basic of your hypothesis. Okay. So I got some answer in chat box. Let me see. H0 is a null hypothesis. Population parameter. Okay. H0 is a null hypothesis. Okay. So H0 is a null hypothesis. That means we are assuming that the assumptions that whatever assumptions we have, we assume it in like under H1, H0. Okay. And whatever the claim which I wanted to do, claim part, I always like I have to use under H1. I can give the very simple example to make you understand why we are using that under H0 and H1. See, when you go to the doctor, suppose you have some problem with like maybe the cough and fever, etc., etc. Okay. When you go to the doctor for medicine, so doctor will assume that initially you don't have any like any fever or any type of like cough. Okay. So initially assume that you do not have any problem. Are you getting my point? So that is belonging to the H0. Even if you have problem, that doesn't matter. So H0, that means I am assuming that the person does not have, like doctor is assuming that the person do not have any fever or any cough. Okay. That may or may not be true. That may or may not be true. Getting my point? So for example, this is one example. Another example, you may consider like you just consider two methods of teaching. Let's say one method from Xavier's college, one method from Junjunwala college. And just you want to compare whether the average methods are like whether these average values of these two methods are equal or not. See, initially you want to assume na ki mu1 is equal to always mu2. That means there is an insignificant difference between these two groups. So H0, under H0 we always initially assume that there is a no difference. There is a no difference at all. We assume that there is a no difference. There is insignificant difference between these two populations. And the further, when we get the data, we checked it, we calculate the t value, we calculate p value, and then based on that, I put the conclusion whether there is significant difference or there is a no significant difference. So that's why this the setting which we do under H0 and H1, that is all very important part in that case. Okay. So make sure that why we are assuming, because this is all null hypothesis, that is all testing we have already done it in your FI level. So just go through and like basics of at least your null hypothesis. Okay. Otherwise, it's very simple. I'm just going to read this all and like I can finish it. But the basic foundation, if you don't know, then like just reading, you can read all. Even you can also read it. No problem at all. Okay. So this is the two things which we have to always take care. One way is this writing v1 is equal to mu2, but I will I feel that you are not it's not like a way of writing. Okay, but maybe if you refer different books you may get somewhere this, but usually in statistical point of view, when talk about statistical point of view, I prefer this. There's an insignificant difference among the group of the population, so population mean you can write, no problem. Or there's a not significant difference versus this significant difference. That much you can always take it. Insignificant, not significant versus significant. Okay. Then the procedure is very simple, right? See, when you just think of when you have two population, you have got the such a complicated like formula memorizing, and like first time when you do it, that it's become difficult. So what you think about three groups, all pairs, it's difficult. So since you can repeat it like three, suppose you have k, na, so you can take one with two, one with three, one with four, one with five, and so on. But you can think how many times you're going to repeat it. So this method is going to be very tedious and lengthy process. So alternative of this is given by the R.A. Fisher. Okay, and that Fisher has given this technique which is called analysis of variance. They have written analysis of variation, or we see the thing is that you can write analysis of variance. Okay, which is called ANOVA. Now under this category, you may have lot of things. Lot of things means I will tell you the like if I talk about one way means I have one factor. I have a one factor. Let's call teaching method. So teaching method is my factor. Teaching. So why it is one way? Because it having only one objective, like not objective is not right word. It has only one factor may be the right word. If I'm saying two way, that means we have a two factors. So if I'm saying one way classification, one way ANOVA having the one factor, which may be the I can say different fertilizer or different teaching methods, different quality of foods. Okay, but they're talking about the like only one important factor, and among that factor you have a several things. Okay, you have a several things. Like if I'm assuming teaching method, the teaching method of our college will compare with different colleges. So teaching method is one, but I'm comparing with the different colleges. Okay, are you getting mine? That's why it's all one way classification. Okay, so obvious if I have a classification, let us assume there is capital and population. There is a capital and observation. Okay. There are capital and observation. So wherever it is not clear, I'm just supposed to be write this, so we can make correction properly. Anyways, you want to write these notes again. So wherever I required, I will make changes there. And obvious, if there is n observations, how that observation look like? Yij, right? Generally we write now Yij. अभी तक आप yi लिखते, that is y1, y2 up to yk, correct? But now we will write yij. Yij means what? I is running from 1 to k. That means y1k. That means this I is changing, right? I is running from 1 to k. So y1j, y2j, and so on ykj. Similarly, I have j factor. So j is running from 1 to ni. So I is change. I will be remain same. So yi1, yi2, and so on yin. These are actually my observations. These are actually my observations. But how you can take this observation? That is a task. Okay, that I will tell you maybe in some of the when we do the real life applications. Okay, that is because collecting these observations is not very simple task. Okay, but just assume that there is a yi observations which contain both the things of a random variables y which are grouped. Can understand group why it is called group because they have clubbed, they have given club data into k different classes by the giving different treatment of a size n1 n2 nk. Means I have n1 having some population having some observation, similarly I have n2 so on nk. Okay, and in such a way that your n capital N is going to be summation of ni and I is running from 1 to 2. You don't forget this two statement. What is that? I is running from 1 to k means we have a k treatment and j is running from 1 to n. We have ni observation and that ni observation such that if you just do the summation I is running from 1 to k, it's become a total of your population. Can you look at how it data look like? This is the way of a data look like. So I have observation n1, n2, nk. These observations are y11, y12, so on y1. This means they have collected like this. Second part they have used it. Okay. Instead of I, they have using 1, 2, 3. Instead of I can use 1, 2, 3. So everywhere, if you just look at here, 1 is fixed. Can you look at here? 1 is fixed. Here 2 is fixed. Everywhere 3 is fixed. So if I'm just do the totaling of this all, total of this all, I'll be called. This is called y1. This is called, or I will be say simply t1. This is called t1. Okay. Similarly, y2, y3, and so on. So if you just add up this, that means you are taking summation over j. You are taking summation over j. Summation over j, right? So if we are adding that summation over j, and if you just dividing by n1, what do you get it? Y bar dot. Just look at it. We have y1, 1, y1, 2, so on y1, n1. So if you just look at everywhere, the 1 is fixed. That's why it is y1. Correct? So to get y1, I need to divide it by the number of observations. So this is going to be what? Summation over. Now j is varying, right? So j is running from 1 to ni. That means ni means n1 because it is number of observation is n1. Y1j upon n1. This is my actually total, but this is my actually total. This is y1 means it is total. But if I'm interested to get the mean of this, so what I have to do? Y1 dot. Dot means mean. Okay, summation over j. So y1 dot become summation j is running from 1 to n1, y1j upon n1. That will give us the, this is also called as t1 bar. But generally you can call this y1 bar. Okay. You can call it as y1. Similarly, you can get y2 bar, y3 bar, and so on yk in usual formula. Okay. Now, but the main objective analysis of the variance technique is to examine whether there is same. You got it in the same thing. You got the same expressions again here. Is there significant difference among the treatment means, or I can say among the populations meaning is? Okay, is there significant? The main objective is this. So the main objective is this. That means that what we need to define mathematical model. We need to define mathematical model. What mathematical model says? Now, as I mentioned, it's a one-way. It's a one-way classification. So if one-way classification, that means I have to define one factor, which is my alpha, which is my alpha. So what is your model? Yij is equal to mu plus alpha I plus Eij. What is alpha? Alpha is my main factor. It's my main factor. Main factor. Okay, which you have to just understand. So what is your Yij? It's a yield of jth observation where ith treatment is applied. It's a yield means it's observations. So see what is the meaning of this? When you use different methods or different techniques to, let's say, new teaching methodology you're applying to your students, and then you are asking what is your experience uh, with after learning this particular softwares and methods, what do you feel like out of 5 points, how much points you're giving to that? And the point which we are getting, that is called 8. So I am applying the ith treatment is applied it, and then we will get the that means I'm applying the technique to my students, and the output which we will get, that's called Yij. That's called Yij. Okay. And then this mu is called overall mean effect, that you are already knowing. Alpha is called as effect due to ith treatment. Effect due to the ith treatment. See, when I applied it, the suppose I have given training to the students. So what is the effect of that training? Do the students can now able to do the task properly? Can students solve the problem by their own? What is their effect? What is the effect of that teaching? Or I have applied it the different fertilizer to the plot. So is that my size of that particular plant is increases? Is the width is also increases? What is my effect? So after applying the treatment, after applying the method, is there is any effect? So that effect we have to measure. That effect we have to measure. That's my alpha I. Similarly, we have error. Obvious there has to be error, because without this error, nobody can survive. Even you and me also. Nobody can survive. See, when you do the task, there is something somewhere, something mistake will be there. That's called error. That's called error. When you study, when you write in practice, there may be you may mistake some alphabets, you may write something wrong. That's called error. Okay, that's called error. So that is not doing intentionally. That is not doing intentionally. That may be happen. So that is called random error. It can be anything. Okay? So we have to try to minimize this error. Very, very important. Okay. This has to minimize. And if I can able to, then my model become good. Okay. So this is all about your model. See, once you understood this one-way model, then our task is very simple. एक बार ये मॉडल आपको समझ में आया तो rest all the model you can understand. I'm telling you. So keep on writing and practice of this models, because I think we have around 50% students in our class. I don't know what happened about the other 50%, but make sure that if they can join, they can get the good advantage of like study. All So again, if I'm creating a model, I have need to put some assumptions, and these assumptions are same forever all the models. Okay, so I think this is already we have discussed. All observations are independent. Different effects are in additive in nature. I think this is the third model we have already discussed. EIJ are identically and IIDs मतलब क्या? Identically independently distributed. IIDs random variables. Okay, identically and independently distributed random variables with mean 0 and variance sigma square. With mean 0 and variance sigma. So just make sure that this should follow with the normal distribution with the certain mean, and variance are remain same for like all EIs. Okay, so that is the assumptions you can just pick. That means this mean 0 variance sigma square already. And the last assumptions, which is something called mm, just a minute. Okay, so this is the last assumptions, which is quite interesting, but a lot of trick is there. When you look at this assumption, something tells about the contrast. Okay, and these assumptions we will look at the end of the chapter in factorial design, how this particular contrast are working.
हेलो सर।
Yes beta बोलिए, can you?
सर एजम्पशन नंबर 3 में EIJ और ऊपर क्या लिखा है? वो EIJ का मतलब EIJ के ऊपर वो हाँ
EIJ
सर वो
ये
हाँ सर
मतलब हम लोग बोलते हैं ना EIJ1 EIJ2, मतलब EIJ मीन ऑल।
यस सर यस यस
जैसे हम लोग बोलते हैं ना आयत करके बोलते हैं, all
यस सर
observations, right? So that is all basically means each EIJ follows like normal with mean and variance sigmas.
ओके सर।
So these are all contrast concepts which you just write it down as it is. Okay. So what is the main hypothesis? See, now they have written in proper way. So ऐसा आपको लिखना है. There is a no significant difference among the effect of all the treatments, because as I said, we are interested to check whether there is an effect of the different treatment on the patient or not. That is, all treatment means are equal or not. That means I'm interested to check alpha 1 is equal to alpha 2 is equal to alpha. Okay. So when we have a model like this, our aim is to be checked with this alphas are equal to or not. तो सब अल्फा इक्वल है कि नहीं है, मेरा ए में है, तो मेरा H1 क्या होगा? All treatments are not equal. That means alpha 1 is not equal to alpha 2 is not equal to alpha 3 is not. But it can happen alpha 1 is equal to alpha 2. Getting my point? Alpha 1 is not equal to alpha 2. Alpha 2 is not equal to alpha 3. Alpha 3 is not equal to alpha 4 and so on. But it can happen that alpha 1 is equal to alpha 3. It can happen alpha is equal to alpha 4. That is called post hoc test. That is also there in your like in your syllabus, that I will discuss maybe in the coming few sessions. So try to understand this H naught. Once H naught is created, just look at this task. What is that? Statistical analysis of a model. Yi we have already seen. Yi dot. Now please make sure that this notation. This notation says a lot of things. Why I dot? Why I dot means what? Means I is there. That means I am working with my alpha I. Alpha, right? Alpha I means is a treatment. Alpha 1, alpha 2, alpha k. So the total of all observation where ith treatment is applied. Where ith treatment is applied. Now, if you just look at this above table, there maybe they have not written properly here. Here you have to make a little bit change. You have to just put your dots and understand. This is the dots everywhere will be there. So I'll just put this one. Okay. So why I dot means I'm when I applied it as a treatment, I will be get the total of all of them. I will be get the total of all observations. So the total of all observations will be addition of all observations with j is running from 1 to ni, which is also known as ti dot. Ti means treatment. So if I'm substituting I is equal to 1, I'll get the first treatment ka total. Second करूंगा तो second का treatment का total and so on. Similarly, the total and similarly it will be mean due to ith treatment. वो कैसे मिलेगा? Can you look at y j is running from 1 to ni, y is upon n, t I dot upon n. This is a total, na? Total of your ith treatment upon ni. What about y bar dot dot? Mean of all observations. देखो अभी यहाँ क्या होता है मालूम है, जब मैं यहाँ पे बार यहाँ पे अटैच करूँ, when I attach the bar of y bar, तो मीन यहाँ आ जाएगा. If there is I, that means mean due to ith treatment. If I suppose I found written here dot j का meaning क्या हो गया? Mean due to jth treatment. See, once you understand the concepts of this dot and I and j, na, ANOVA doesn't matter. You can do whatever you want with derivations. Try to understand only the concepts. So in examination it happens I ka j, so don't get confused. Don't get, apply some logic. Apply some logic. जैसे कि I have given one example like which of the formulas most suitable. तो proportion के बाद optimum आ गया, but you look at the formula at least ना. Don't go with the notations, but look at the formula, which is more suitable for that. Getting my point? See, it is a matter of all doing with the notations. So if you like try to like notations means even I will change with the j and j is change with I, then the whole thing goes wrong. It happens. It happens, right? So try to understand the concept. That is the very, very. So if I'm putting I dot, that means ith treatment is applied it with mean. So it's a mean due to ith treatment. If there nothing is there, that means it's a grand total. It's a mean of all observations. It's a mean of all observations. और all observations बोला तो दोनों summations आएंगे. I भी आएगा, J भी आएगा. याद रखो, I is running from 1 to up to K because there are K treatment, and J is running from 1 to up to Ni. Means up to Ni. And when you talk about grand total, तो grand total कैसे मिलेगा आपको? It is double summation Ij, Yij upon capital N. Capital N means what? It's a summation of your Ni. Okay. So this is called grand total. N is called total number of observations. Okay. Any questions so far? Let me know if you have any question. Yes. Any question? Okay. Now, as I said, this EI this EI we have to minimize. Just think of if the EI is not there in the model. So what happens? There is no error time in the model. Means my treatment, the treatment which I am using, the treatment which I have applied it to the patient, that is successfully, very, very successful. Very, very successful. Obvious, na? Meaning is that only, na? And once I have introduced EIJ, that means there is something problem with my treatment. And there is something side effect with my with my medicine. So that's why EI comes in picture. तो EI का मेन फंडा क्या है? We try to minimize it. That जितना minimize कर सके उतना minimize करो. But how? So minimization technique you should know. I think you are already knowing this technique. We have already seen in the least square method. So there's only one method is available in your portion. There is only one method which is called method of least square. There are other methods, but not there in your syllabus. So you can use least square method. What is least square method? First derivative equated to 0. Minimization. Remember, you have to minimize, not maximize. So first derivative. So as I said, first derivative equated to 0 means what? Means it will be like this. Minimization. Na? So it will be minimum and then it goes to the maximum. So first derivative equated to 0 and second derivative should be positive. See the condition. Let us see the condition. Can you look at here? I think they have not given second condition, but you should go by second conditions also. But that's okay. That's okay. But just understand. When you try to minimize anything, make sure that your first derivative equated to 0 and second derivative should be positive. The concept of yaad rakho hamesha. First derivative equated to 0 and second derivative should be greater than 0. Then only you can call that technique will be minimization technique. And we are using here least square method to minimize this concept. Fine. So what is the minimization condition? Error sum of square is equal to summation I is running from 1 to k. So I will not always say 1 to k j. I will simply say to summation I and j. I bola to just remember I is running from k. J bola, j is running from 1 to nj. Sorry. Just remember like this, okay? So summation over I and j, eij ka whole square. Now what is your eij ka whole square? What is your eij? What is your model? Yij is equal to what? Mu plus alpha I plus eij. So what is your eij? It will be what? Yij minus mu minus alpha, right? So square क्या होगा? ये होगा. That is the substitute. Right? Now this we have to minimize with respect to the parameter. The parameter क्या क्या है? We have two parameter mu and alpha. Mu and alpha. So minimize. Minimize to minimize error sum of respect to the parameters conditions are. So you can call this is E. Right? So derivative of E with respect to mu equated to 0 and derivative of E with respect to alpha I. This is alpha I, don't get confused. Alpha I equated to 0. Or and derivative of E with respect to mu, second derivative should be positive and derivative of E with respect to alpha I is also. So this is the two condition you have to write it down. So whatever extra I'm writing now, you need to be just while writing your notes, you can just put it, okay? Because that some part is missing there, so you can just remember. So abhi mujhe just tell me whether if you take derivative respect to mu here, what could be your answer? So it's
minus
a 2,
1.
yeah, it's a 2 minus 1 time, or even 2 will come because,
Yes, sir.
yeah. So it's a 2 time double summation yij mu I alpha I, and again derivative of again mu I, which is minus 1 and equated with 0, right? simple derivative. Then this is a constant, goes left hand side, right hand side, equate. Just try to get it in terms of uh, this is equated with 0. So you know this condition. This condition means your Ni alpha is 0, right? By assumption. So if Ni alpha is 0, that means what? This term is 0. See, when you open the bracket, Yij इसको देना पड़ेगा, इसको भी देना पड़ेगा, right? Both summation will be given each term. So double summation Yij minus double summation of mu, but mu is constant and double summation का total क्या होता है? Capital N. जैसे सिंगल समेशन होता है उसका टोटल क्या होता है n स्मॉल n, वैसे यहाँ पे डबल समेशन है मतलब टोटल कितना होता है कैपिटल n. आर गेटिंग माय पॉइंट? बट व्हाट अबाउट दिस क्वांटिटी? हियर वी हैव डबल समेशन व्हाट अल्फा I j I n j, but how did you get this ni alpha? How did you get this?
सर जो सेकंड समीशन था j इक्वल टू 1 to ni वाला, उसमें उससे ni मिला और एक समीशन को सर वैसे ही रखा.
Exactly, because here if you just look at alpha I, it is independent of j ना. तो मैंने क्या बोला था, independent of j मतलब क्या, जो whatever n is there that is to multiply summation over I and ni alpha. So that step they have skipped. So you don't get confused. So while writing your notes, you write it on your own step, no problem. And once it is equal, you know this condition, this is the assumption, which is 0, and hence it is 0, so this is equal to this. And hence it is equal to 0, you can compare it, you'll get the mu hat, which is y bar dot dot. Any doubt? Just go through and tell me if you have any doubt. Similarly, you have to do it with respect to alpha. Alpha ka bhi same concepts hai. Just look at 2 minutes. If you have any query, then tell me. Can anyone tell me we are taking derivative with respect to alpha I, but here we have this summation, but where is my I can't see here I. That range for I is where missing, is that missing or where it is gone? And if it is gone, then what is the condition, what is the assumption? Yes, anyone can apply their knowledge and ideas. Yes, see, when we have a joint distribution x and y, if I tell you can find marginal distribution of x, तो क्या करते हो आप? You take summation over y, right? Summation over y, and you take that function of f of x comma y. Similar condition you have to use here also. If I'm taking with respect to alpha I, you have to take summation over j. Okay, so that concept you don't forget. So that is the important part you can keep remember. So you have to take summation over j up to ni, and then it's become simple. Again, minus 2 time, because alpha I का derivative लेंगे तो -1 आएगा. Then put summation inside everywhere. So summation ij, summation mu, summation means I'll just open the bracket. So again, this is, you know what is this? Constant, so ni. This is again same concepts. So ni alpha equal to 3. What is this? Summation over j. j लिया तो dot. तो इसका sum क्या होगा? Dot. So y I dot. This will be as it is. This will be as it is. Now divide by ni. So if you divide by ni, तो ये क्या हो गया मेरा? Y bar हो गया. ये mu हो गया alpha. But just now we have found that mu hat, that in my that I can say, or I will just calculate with first alpha I. Alpha hat क्या होगा मेरा यहाँ पे? It's a y bar dot minus mu hat. Right? Now I'm using hat here. यहाँ तक okay. इसके बाद मैं alpha I निकालूंगा. Alpha is equal to what? Y bar I minus mu. And the next step I will take hat. Hat क्यों? Because I know the value of mu hat.
Hello
mu
sir.
mu hat मेरा y bar dot dot है. यहाँ पे substitute कर दिया. So alpha I become, alpha hat become y bar dot dot. Y bar, y I dot bar, or I will say y bar I dot minus y bar dot dot. This I will stop here. I don't know.
Hello
how
sir.
much. Yes बेटा बोलो.
सर समीशन को रिमूव करने के लिए वो डॉट को यूज किया है क्या?
हाँ.
y dot.
ये ना?
हाँ सर हाँ.
हाँ. और even if you don't remove summation, इसको as it is रखो ना, क्या फर्क पड़ता है?
सर डिवाइड बाय ni करेंगे तो भी वही आएगा.
डिवाइड बाय ni करें तो भी आएगा, क्योंकि मुझे मालूम है this upon ni is going to be simple y bar dot. मैंने
Yes,
पढ़ा है अभी. ये देखो इधर देखा. Just now we have read it. See, this upon ni करेंगे तो y bar dot आएगा, तो भी चलेगा.
yes sir.
Means see there, I told you there are different way of writing. If you want to write like this, you can write, or you can ni बाद में divide कर. So till here I stop. Any question? Tell me. Now the first and the most task is that for you, you download this PDF file and write it down. ठीक है? अभी आपका बुक निकालो थोड़ा फ्रेश होके. ये नोट्स पहले आप लिखो. एक बार आप ये नोट्स लिखोगे ना, तो आपको क्लियर समझ में आएगा कि ये डॉट कभी लगता है और डबल डॉट कभी लगता है. ओके? Otherwise you will be get confused between the dot, because once we have started like very smoothly ना, तो later on इसमें सब dot 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 फिर पूरा dotted mix नहीं होना चाहिए. Okay? So that is the task you can always remember.